We have an example of radioactive decay. The data of nuclide in terms of time and the counts is given in this table. So objective is to draw this data. So I copy, select this data and paste this one in the Microsoft Excel sheet. Over here. Some size increase. So data has been copied. Okay. So two columns, one contain the time data. So it is like getting the activity at the time was equal to 4 minutes, then at 36, then at 68, then at 100. And generally, while taking the measurements, we keep the time interval almost constant, like getting measurements after every 2 minutes, after every 5 minutes. So in this demonstration, let's first plot it, how it looks like. So I go to the insert, there are chart options. I prefer the XY scatter. So by making a click on it, it will create a blank figure because the data was not selected. After getting this page, this chart, I select the data by adding a series. And this is for the iodine 128. So I label for the series and X values. On X-axis, we have time in minutes. And for Y-axis, I will pick up the values from this column. These are counts per second. The detector reading for decay per second. So of course, it requires some of the efficiency things. Okay, so we have got this type of curve. So where the blue dots starts from some number below 400, and for the time minutes, they end up to a value. So if we consider a straight line, that is not the logical option, right? So we have to consider something else, right? So to do that, I make another graph. I will make another graph and see what I'm going to do. I'm going to consider the natural log of R. So I perform a calculation, log of this log in Microsoft Excel returns the logarithm of a number to the base you specify. So let's consider the ln. Okay, returns the natural logarithm of a number. So I get this one. Okay. So oh no, only for one number, e2. That's fine. So I have got the natural log. The title of natural log has been changed to like somewhat like registered here, right? But the rest of the thing is fine. Now I make another graph, insert. So please note that in the next graph, okay, it has already taken the values. Let me first move this one to make it separate. I move this charge to as a new chart. separate to the sheets. The markers are very small. So can I change the marker size? Okay. This is the marker option. These, I think this is the size. Okay, they are visible. So now it has become a straight line, right? So I can do the regression. For the time being, let's do it in the Microsoft Excel directly. But that is the learning of this process is due, right? So a linear line has been fitted to that, a straight line, and then let's ask it to write the equation on chart. So we have something appearing on the chart. To show this one, I ask it to show it with the bigger size. Okay, so it is 0.86692x plus 6.793. So on y vertical axis, we have log of r, and on x axis, we have just the time. At this point, let me do something else for this chart 1, in which we plotted r and time, r as a function of time. So if I change this scale, vertical scale, we have the format axis. So here I have the option logarithmic scale. Logarithmic scale. So it shifts that one to a straight line. I have changed the scale. So I have got the straight line. So two interpretations are identical. One interpretation, change the vertical scale and the data falls on a straight line. The other interpretation in chart 1, change the values, take the log of the values of the r count, and you get the straight line. It means you have similar information in two representation, right? So, and you have the equation printed here. Let's move further from this equation. And here I just uh, state the result. It means there is exponential relationship. There is exponential relationship. If you take the logarithm of the vertical scale values, right? Data values, it falls on a straight line, there is exponential relationship, which you can discover from this equation. And similarly, the other interpretation says if you change the vertical scale to logarithm and the data falls on a straight line, it means still there is exponential relationship because one of the scale is logarithmic.